Welcome to another edition of the Sim Racing Garage. I'm Barry Rowland. In this episode, we'll be reviewing the latest direct drive force feedback wheelbase solution from the guys at MOZA Racing, the R9, along with their latest steering wheel, the GS. This looks to be a good match, with the R9 delivering a 9 Nm peak torque rating and the CS sporting a one-piece 5mm thick forged carbon fiber front plate. Time to put them through the SRG's review process and see how they do. So, let's get to it. Let's take a closer look at this MOZA R9 wheelbase. Out of the box, has a very good finish on it, just like everything else from MOZA that I've gotten here at the SRG. Everything's done well. I don't see any defects anywhere. It's just professionally presented, just like all the rest of their products. And it looks like they've got some pretty good quality control going on down there. It's small. We'll talk about the dimensions on it. I think I've had it 240 millimeters long here. Yeah, 240 millimeters or about 9.5 inches as far as the total length, all the way out to the end of the tip of the wheelbase adapter there. Now we have it at 224 millimeters tall. And that comes in close enough to 5 inches. And then it's a little bit, it's not a complete square here. It's a little bit wider than it is tall. Comes in at just short of 160 millimeters, about 158 or so, which will put us around the 6.25 inch mark. All right. The weight of this thing, 10 pounds, 3.5 ounces, or 4.63 kilos. So again, the finish looks good on this. I'm not sure if these are real cooling fins or not. It's only a peak and 9 Newton meters as far as the power of this motor. And that's peak, so chances are you won't be running 9 Newton meters all the time, because that's where the peak power is when you get the jolts, like going over curbing, sausages, things like that. The casement is all metal. It's metal on the hub here, and of course the adapter is steel too. We have an LED indicator light here, so when we power the wheel up, we can see that it's powered up. We got some, looks like some, I don't know if this is kind of raised here. Doesn't feel like laser etching, but it doesn't feel like a decal either. Same thing on the sides here. It's like it's almost painted on somehow. And on the bottom, we have our mounting configuration. And our mounting configuration goes as, let's see, I believe it's 66 this way. Could be wrong. It might be the 78 parameter. Let's go ahead and mic it out real quick. Yeah, 66 millimeters this way as far as the length. And if we mic it out the other way, it's 78 millimeters. They got it in their manual as 78.7. But I think you could probably get away with a little bit less or a little bit more than that, depending on the size of the hole in your mounting bracket. And these are tapped holes. These look to be M6s, I would imagine, for a wheelbase. Wouldn't be M5s. The back of the wheelbase has a plastic piece on it. I got my fingerprints all over it. Got the MOZA. This is an injection molded piece of plastic, obviously, with all of our interfaces back here. We've got the power on and off. We've got a DC connector for power. We've got our USB-B, and then we have an e-stop, and we have a meter. So a couple of accessories that you can plug into this. Definitely plastic for our electronics packages in here. And yeah, there's not a whole lot to look at from just doing a closer look at what this wheelbase is looking like. Of course, obviously this looks like another wheelbase that came out a little while ago as far as the shape on this. And it makes me wonder, who's making all these parts for all these companies. If it's just one or two factories, or, and they're licensed to produce it to sell their own stuff. I don't know how that's working out, but yeah, we can definitely see some similarities or resemblance in this. So what comes with your wheelbase? Of course, you get a power supply. And this power supply has a little V, or XVE, that lights up green when we power it up. We've got a 6-pin plug here, but there's only 4 pins in it. See that well enough. And on the back, this says this is an AC DC adapter, XVE. The output is 36 volts at 5 amps. You can read that there. And I also noticed on this, we have a red light means charging, green light means charge full or disconnect. You see that written down there. So what that tells me is this is also a charging power supply. And what that means is we've got power and negative pins on this, but we also got a data pin, 2 data pins. And they talk to, if you have a charging unit, there's usually a BMC in there, which is a battery management circuit board that charges the batteries. So you power that, and that does the charging. So, and it communicates with this as far as it's kind of intelligent, if you will. So it'll tell this, hey, we're charged fully now. You can change from green to red or red to green, whatever the case may be. Anyway, we've got a standard plug here, like on the computers. The power that they sent to me is a little bit different than what we use over here in North America. So I've got plenty of plugs, though, with the end like this on it, so it's not a big deal here. And that is a switching power supply, so whatever you plug into here, it will compensate for and send the right DC power to our wheelbase over here. We also get this, which is a USB, and of course it has the USB-B over here. No gold plating, anything particular. It does have a, this is not a clip-on, is it? No. This is a molded-in ferrite core to help mitigate our EMI issues if you have them. We also get a manual and some stickers. So yeah, that's about it. Of course, you know, what do you expect to get with just the wheelbase? A way to power it, and then of course we're going to have to find our own wheel to put on the front of this. So when we come back, I'll actually talk about the new MOZA GS steering wheel. Now let's take a look inside of this MOZA R9 wheelbase. First, I've taken the hub assembly off and the electronics so I can show you this part. And this is just a plug that plugs into the back electronic board, the main one. And remember, this provides power to our steering wheel back there through an inductive system, electromagnetic induction. And how they do that is we have this piece here that is sitting on the front like so. But underneath that, we have this assembly here. Now this is a coil. You see our little white wires there? So we've got a coil in here. And this coil sits inside of here once we have this screwed into this plastic part here. So that's sliding inside of here. And this is just plastic, I believe. Can't see anything else in there. So the coil slides in this. And then once these two are together, then we have another coil, receiver coil there. And that slides into that, like that. It's sitting in there. So when we induce a current into this out, this coil, then we induce a current by electromagnetic induction into the other coil. So this will be the transmission coil, that's the receiver coil. Also on this board, you'll notice on the front here, we have a wireless transceiver. So we have a wireless transceiver in the front, so that means it's facing towards the back of the wheel. And if you saw the look inside on the wheel, you know we have a transceiver. See, what side was it on? I think it was on this side or it's on this side. But it's plastic back here, so it passes through with ease, if you will. In other words, if it was metal, it wouldn't do that. We had to put a window on it. But we have one here. So we have a point-to-point, direct point-to-point wireless transfer of data going on, which is better than having, in my opinion, some kind of a antenna sticking back here. Even though they both work, obviously it just makes sense that closer you have your wireless transceivers, the better the signal is going to be as far as resistant to EMI interference and things like that. Right. So that's this module. And again, the electronics are done quite well. Got a little piece of electrical tape here. I'm not sure why they have that there, but it's a very well sorted board. You see we got some numbers on the bottom there. There's our coil in the front. There's an LED. Where is that LED? I saw it a minute ago. There it is. This little LED here. That is the indication for the motor power. So it's got a little blue LED that shines through our little cap here when we have it on. Let's see, where is that window? And there it is. So it shines through right through there. And of course, once we have the power induced into our receiver coil back here, that is wired up to our circuit board in here. Best way to show you this, like this maybe. And like that, there we go. Again, well sorted, got some inductors, capacitors, the usual suspects there. And of course the cable coming out. And that cable is going to plug into the board here, little circuit board on the front. You can see we had a couple of screws holding there, and of course it has some pads here. So once that's plugged in, then we have the power to the pads. And if you saw the closer look and look inside on here, and then you know we have some spring-loaded pins inside of our hub here that contact those pads and maintain that contact with the spring action. And that's how we get power to the wheel. I'm looking for things to complain about here. I'm not sure I can find any. It works, and I really like the idea of having the transceivers facing each other like that does here. Right, so we got one on the wheel here. So I really like the way they do that. And using the inductive transfer of power means we have wireless. So nothing is spinning. This motor shaft can spin here, and we don't have any wires spinning inside of the middle of it like some wheelbases are made. So yeah, that's going to obviously be a more durable solution in the long run. All right, so that's it for the front, and we'll get to the rear of the motor next. So now we're at the back of our R9 direct drive force feedback wheelbase, and I've got some few things taken apart. I've taken the cover, little black cover that has little ports in here for our interfaces. And that's just plastic, by the way. And of course, first thing we see here is the interfaces on that cover. We have our power coming in here. We have a power button over there. And we have some USB and data interfaces. One's for the emergency stop, and the other one is for the display. And you see we got these two very large leads coming off of here, or wires, going to the main board sitting here. And I have that loose too, because I'm going to show you some things behind there. Get this sit right. Okay, there we go. So we have some capacitors here because they're smoothing capacitors because of this power coming into the main board here. They are 63 volt capacitors. So plenty of potential there for smoothing. We have some transistors, power transistors here. We have 6 of them. So all this is part of the power circuit. We have an inductor over there. And I believe this is the main processor sitting up here. We have another one here, but I think this is the main one. I can't be sure because I don't have the schematic with me. We also have some plugs here that I've taken loose. This plug went over to the board here on this little piece there. We also have a plug here that goes next to that. You see a little plug sitting there. And we have another one, this plug here, that's going through the big resistor we have here. That's a 75 watt resistor. And that's for, obviously, there's going to be a lot of current flow through there. You need a physically large resistor to be able to handle that, and it even has some cooling fins on it. Now, the reason I took this off is because I wanted to see what the position sensor circuit was looking like. Now, this is wires that go to the front of the hub, and that's providing wires going up to do the, if you saw, you'll see that in the first part of this if you haven't seen it yet, and that's where the inductive coupling is going on. Now, you'll notice there's also a big ferrite core here that this is looping through, which is a good thing to see because, yeah, they're trying to mitigate EMI interference as much as possible, and wrapping through a ferrite core like that really helps that. All right, so now I'm going to very carefully pull the board away. Remember, it's always easy to hurt something doing this. You have to be careful what you're doing. And I'm also going to flip this sideways so I can open this like a door, if you will, like this. Here we go. All right, so here's what we see is going on here. And we're getting a better look at this 75 watt resistor here. The shaft itself over here has a magnet cap on it. If I turn the hub, you can see that's moving. And of course, the magnet has magnetic fields based on the polarity, which way is which, north or south. And then, of course, those magnetic fields, as we turn that magnet, are going to be changing their position relative to this sensor here. And this white circle here, that's where our position sensor is. So as that magnetic field changes its position, this little chip will pick that up and be able to tell the rest of the circuitry what's going on as far as the position of the motor, and that's how it's controlled with our telemetry streams coming off whatever game that we happen to be playing. And again, on the back of the circuit board, just like the front, very good looking, well sorted, just professional looking stuff here. And I wouldn't expect anything less. So far, what I've seen from MOZA has always been like this. Got a power transistor here. Yeah, so very clean looking inside. I'm going to go back over here. We have now remember, if you saw the front part of this, let me turn this over again. The front part of the hub has a wireless transceiver in it. But if you notice, we also have one up here. So I guess it's some kind of a redundant situation there. So if the one in the front fails, we still have one out back. That's the only thing I could think of. Because, you know, the ones in the front talking to the one on the wheel in the front being in close proximity like that, obviously the less length or distance your wireless signal has to travel, the better chance it has of not getting disrupted. But yeah, that's what I have to assume that's what that's for. That's just a backup. So another transceiver back there for that. So yeah, that's about it for the back end. Again, well sorted. I don't see anything I can really complain about here. Just well done, I think. Let's take a closer look at this GS wheel from the guys at MOZA Racing. Now this is their new wheel to add to the other wheels that they already have in their lineup. This is going to be their, obviously, their Formula and GT type of wheel. It has a 300 millimeter diameter to it on the grips, and the grips look a little familiar as far as their shape. They are Alcantara, so they provide a decent grip. There is a noticeable seam here in the grip. You see how much gap there is in that, and that's feelable. Plus, it's the same gap inside where your fingers are wrapping, so I can feel that as I'm gripping the wheel. With gloves, maybe not so much, but yeah, there is a seam there, which can be something that you can complain about or just don't worry about and get on with your driving duties. But this is a replaceable grip. You can see it on the back here. We have some screw holes rather. Got some over here. Got one over here on the other side. And then we have one down inside of there. You see that one? There it is. So these are replaceable. And there's even aftermarket grips that probably will fit that because it looks about the same size as a Fanatec. I don't have a Fanatec F1 wheel with me, so I can't tell for sure. But they make aftermarket grips. If you don't like Alcantara, you can get like a rubber or something. So it's good to see other options coming out there. But being replaceable is also a good thing. So if you wear them out, gouge them, you get something wrong with them, you can switch them out. So that's a good thing, I think, in a wheel. Now, this wheel is all a one-piece carbon fiber plate that everything's mounted to. And of course, you can see this is a forged carbon plate. And the forged carbon is just a bunch of carbon bits that are compressed together, high pressure and all that kind of stuff. But you can see it's kind of neat the way this changes as we go through the lights. You can see there's like a little shift in the way that these pieces of carbon are reflecting that light. I think you can see that there we go. So it gives kind of a marbled look, a little dimensional look to it. I got some greasy fingerprints on here. And it's 5 millimeters thick. You can see the layup there. There's the layers of the carbon. It is a solid piece because we can go around the back and see on the back of our handles there. You can see it's still forged carbon fiber. So a decent looking wheel. You know, it presents well, just like all the MOZA stuff. It's right up there with, you know, the Thrustmaster Logic, any of that stuff out of the box as far as well, you know, their top end stuff presents. This presents well too. Fanatec, any of that stuff. It's almost like they're making it in the same place. So anyway, the button layout on this. Okay, so we've got, 5 buttons on each side. Now the buttons themselves, nothing to get excited about. You know, I'm sure they get the job done, but there's no real tactile click to them, just kind of a stop, which is what most buttons do. But yeah, it's like I said, it's nothing to get excited about. But I'm sure they'll do their job. You just press it till it stops. They do have some guards around each one of the buttons as we go around here, which is good so you don't accidentally whack one of the buttons with something and break it. Always good to see those. The encoders, thumb encoders on each side. Now these I like. These have a good tactile detent to them. You can hear that. That's solid feeling. And there's not a lot of play in the shaft. Now you have to have some play in the button shaft, or obviously it won't turn. It's also a button. So when I was playing around with these and turning them, this is probably one of the better encoders for thumbs that I've had because it's easy just to grab one because of the spacing and the feel of that detent. Very positive engagement. And you do have to put some force to get it to go out of that detent into the next one. And the buttons also, again, very tactile. More tactile than these guys are. So yeah, I like these thumb encoders. Some of the better ones, like I said, that I've tried. Now knobs on them, I can't tell if they're plastic or aluminum. You know, and sometimes you can tell because there's a set screw in there, but there's no set screw in this one. So that's the way I attach it. So, you know, I'm guessing it's plastic, but it does have some nice sharp, well, not sharp enough to cut your fingers, but to engage your finger or thumb skin when you actually turning it. So yeah, I'm thinking these are probably plastic. The thumb pieces over here, of course, we got some 2 D-pads and their buttons. So we can press them when we want to. We can program these to do what we want them to do. They can either be a button or it can be an analog axis like a regular D-pad on either side. There's a lot of programmability built into this wheel. The buttons have colors on them that we can change. We'll go through that later on. And let's see, let's talk about these encoders. Again, these encoders are very good too. Very positive detent. You have to put some force in it to move it, and it has a very solid stop to it. And yeah, nothing to complain about here. I like these encoders. And I don't like a lot of encoders, but these right out of the box, they just feel, okay, yeah, that's the way it should feel. Like you're really in a car turning something. Just gives you a good detent. Of course, that's subjective. Some people might not even like it, right? So that's all of our controls. We can also, by the way, program these two to be like a selector, where it's selecting different things as we turn it, or just as a regular rotary encoder that just goes plus, 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 minus, 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 and one button or the other, so we can change things. What else here? I guess that's about it. Oh, we got the RPM indicator on the top, little window there that changes colors. Go around the back. First thing I do when I grab a wheel is play with the shifters, because obviously that's one of the major interfaces we're going to be using while we're driving. And these are loud and proud. They feel good. They have a good tactile feel to them. It's sharp, precise, but not so sharp that it feels metallic-y. Like if I had a metal shifter paddle on a metal shifter lever and snapping it, it's like you get this little vibration in it, or a frequency that's uncomfortable for me. This carbon fiber paddle here dampens that. And these are 3 millimeters thick. And of course, they are also the forged carbon. They have no slots in them. So the angle is what it is. Might be able to adjust it a little bit, but that's pretty much is what it is as far as reach and everything. And which reach is fine for me. Yeah, I don't have any problem with that. And of course, this is all aluminum on these clutch shifter housings, all aluminum. The levers are aluminum, obviously, and they're rotating on some nylon bushings here. So they feel smooth. The clutches themselves, decent spring pressure. If I'm going to be driving and releasing the clutch, yeah, that gives me a good feel for the progression of what's going on as far as when I'm doing that final release of the clutch to get going. When I release the bite point, then we let that one out. So we'll have to see how that feels, or what we can do with that in the game itself. Now, also you can use these as regular analog throttle and brake. Again, a bite point type clutch, or even buttons. If you just want to need extra buttons, you can map them in the software. Pretty cool, huh? The back of this is all injection molded plastic. So I thought that was aluminum when it first took it out, but yeah, it's definitely plastic. Now the quick release here, what I call the NRG type or ball bearing type quick release, that's all metal, obviously. And the flange that attaches to the wheel itself is also metal. Kind of the bolt pattern that's familiar with some of the other manufacturers out there. Yeah, so nothing to complain about here, I suppose. Now, inside of here, we've got these pins. Now, these pins are spring-loaded. They're gold-plated, spring-loaded pins, and they're made so when we put this on our wheelbase, that the wheel gets its power through these pads here on the front. So the pins will contact that and push in a little bit from the spring pressure, maintain that contact. So we get power through the wheel. And of course, we're using an electromagnetic inductive coupling type of solution inside this hub to get the power to these pads. So there's no wires connected in here. You can just spin this forever and nothing will ever happen as far as tangling up a wire internally. So that's how this is working as far as the power transfer. What else can we talk about? I think that's about it. You know, it seems to be a well-sorted wheel. I would like to see aluminum here instead of plastic, but I doubt I'm going to be able to feel the difference in how rigid it is. Maybe I could, But yeah, we still have this very thick 5mm piece of carbon plate here that's really going to be all the stiffness that you need. There's no noticeable flex detectable. Once I have it mounted, maybe there will be, but yeah, this is a tight steering wheel. I'm looking for things that I don't like about it. And I guess the only thing is this, and that's aesthetics. It's not so much this part of it, but the internal part. When I grab it, I notice it right away as soon as I grab it, because my bottom two fingers are falling right in that crease. That's a better way to look at this. You get it further away from the light, you can see it. But yeah, you can feel that with your fingertips, because the size of my hands, that's where they end up. And that's why I noticed it. But other than that, yeah, I think this is a well-sorted wheel, and we'll have to wait and get it on the rig and get it mounted to our R9 wheelbase here to see how it performs. Now for our look inside on the MOZA GS steering wheel. First thing we see when we pull the back off is this well-sorted circuit board. Definitely a high industry standard production here. All of our encoders on the front are actually a through type of connection on the board, so they're kind of raised up. You can see the pins there, and then they're all soldered in, and we have a bunch of resistors around each one of those encoders in the supporting circuitry. We also have the thumb encoders over here. They have a little wiring harness that clips into a plug over here, and over here we have the main processor, which is an STM32F4, which is fast enough apparently to do all of the calculations for the different feature sets that are available on this particular wheel. And if you look at the MOZA Pit House software application that comes with your wheelbase and wheels, that allows you to change the functions of the knobs and the D-pads and the RPM indicator. Over here, we have the wireless transceiver, and that's how we send data back and forth to the wheelbase. And you can see a little antenna array down there. Now, the housing on the back is an injection molded plastic, so this does not have any problem going through that. If it was an aluminum, then they'd have to put some kind of a window in there so it could pass the signals without any interference. But we do have the forward facing from the wheel to the wheelbase. We'll do a look inside on that one later. What else is of interest is on here? About it is a very clean sorted board. There's no kind of etching, identification, or anything like that. It might be on the other side of the board. We have these LEDs up here. You can see how they put it. Looks like I put a piece of electrical tape up here to shield it from any light bleed. What else can we look at? That's about it. The D-pads. Let's see, I got the handle over here off so I could show you something else. Then we got our little D-pad in there. So we move that around. You can actually see that middle piece moving. Now, I did take one of the grips off so that we can see that indeed this 5mm thick carbon piece here, the frame, is a one-piece unit. It actually supports the handles too. And I thought it did because it felt pretty stiff underhand when you're using it. I really couldn't feel any flex or softness in it. Now, there was a minor amount of flex in the quick release itself, but I really had to put some pressure moving it back and forth to get anything out of that. But the wheel itself certainly is very stiff indeed. And where we mount it, I'm going to show you that in a second here, and how they mount it contributes to that also. But yeah, forged carbon fiber, 5mm thick plate is the complete wheel. And of course, that's 300mm from grip to grip. All right. This is the grip, by the way, as it came off. It looks like this could be easily replaceable. It was only 3 screws to pull this off. And a decent job here. I can't see anything to complain about where they've split the Alcantara material and wrapped it in and glued it in. And nothing's coming up, in other words. It's all securely glued down. All right. Now, the back plate is plastic. And I said, and I may have mentioned a couple times, that I wish that this was aluminum. I'd rather see this in aluminum. And then I look at the price of the wheel, you know, $500 plus shipping for this wheel with all the feature sets it comes with. I mean, we've got these photo sensing switches on the back here for the clutches and the shifters themselves. Yeah, all the functions that are built in that wheel as far as controlling things. I'm kind of seeing why they went with the injection molded plastic for an economy here. They got to find some economy somewhere. And the way they built this is pretty clever to make it still remain a stiff wheel. What they've done is put this 3mm thick piece of steel in here. This is all a steel plate, kind of a stamped looking thing, right? So the carbon fiber plate mounts to these guys here. Now we do have some supporting standoffs in here that are for other screws in the front of the wheel on the carbon plate, but they're not real load bearing like these are. So this is where all the stress is going to be taken up on the wheel as we're turning it, and that frame, that carbon fiber frame, is translating it to this steel plate, which is very stiff, as you might imagine, especially at 3mm thick. Now, on the other side of this, we've got the quick release. And of course, this is all steel too. So very thick steel, 3mm too, right? So this is mounted or securely bolted to from the back here through this plastic into that steel. So that gives it a lot of rigidity, as you might imagine. And then we bolt the carbon fiber to the front of this metal plate, and same thing, right? So they've done their homework, and because they're not using a stiff aluminum housing back here, which, by the way, certainly would raise the cost of production on something like this, as you might imagine. You know, taking a billet piece of aluminum and machining out a shell that would be the housing, you know, removes a lot of material. So yeah, it's not a cheap way to do it. This is much less expensive, I would think. But it's still, because of the way they've done this and everything bolts together, provides a solid piece to use when in hand. So it feels very stiff in hands, my point. Now, because we have this already out, you can see that there's a wire here. That's the one that was flopping around. That is the main power wire. This actually powers our board through the quick release. And of course, those are the pins. You see the gold pins on the internal part. And of course, that's the other side of them. We have a little Molex plug in there that the other piece will plug into. And there you have it. And of course, this is the quick release itself. It has 6 bolts bolting to this, and then we have 6 bolts bolting to that metal plate. So a very solid unit when you have it in hand and mounted to that R9 wheelbase, the way we had it mounted. I think this moves around a little bit. If you want to, you can twist this, I think, a little bit. Maybe not. Looks like it wants to spring back. All right, so what else can we look at? I think that's about it for the look inside. Not much else to show you. But yeah, I think at $500, now that we've taken this apart and looked at the assembly and what's going on everywhere, and the feature set that they have put on this, as far as adjustability of controls and, you know, LED colors, things like that, yeah, I'm having trouble finding fault with this design. Except for, again, just from aesthetically, I'd like to see an aluminum housing, but I know that if they went with that, it wouldn't be a $500 wheel, now would it? So anyway, there it is, the look inside for the MOZA GS steering wheel. So now we're going to get our wheelbase mounted to the rig, and if you saw a closer look, you know that they have a pattern in here. Now this is a proprietary pattern, not a standard pattern for, like, you know, the Thrustmasters, the Fanatec's, things like that. They have their own pattern, which is, of course, right? Now, they do make an adapter on their website that's an accessory. It doesn't come with this base, that will mount to, you can screw it to a mount like this one over here that has the triple pattern Fanatec, which a lot of them do, coming from cockpit manufacturers. So if you have that triangle looking pattern, then you can bolt that plate to that. And then that plate in turn has 4 holes spaced for this that you can bolt this to. So they do make an adapter plate for it. I went a different route, although I've already done this for something else because it just happened to match up with, you can see my used and abused front plate mount here. Deck mount, as they call it. So I've drilled a few extra holes in this. You can see from the silvery parts. If you look down inside there, the silvery parts, those are extra holes for different patterns on wheels that I've used in the past. And I've tested a lot of wheelbases, so that's why you see this. But it still has a lot of structural integrity. I'm not worried about it, the stiffness. I mean, it is a solid piece of 10mm aluminum here. I've got my bolts on the side here that will slide down into my wheelbase uprights and attach this once I have it mounted. I'll probably mount this first and then mount the wheelbase to it. But before I do that, I'm going to want to go over here and turn this upside down and do a test fit, so I don't get any surprises when I'm over there and everything's sitting there and I go, well, you should have tried this, Barry, and then I got to take this back off and maybe drill another hole or something. So anyway, that's just a process that I use. Now, I'm just going to turn this upside down, obviously, and orient this bracket the way it needs to be set up to match the holes that I have in here right there. So this hole's, okay, so this hole, this hole, this hole, and this hole match. So now they don't give you any hardware with the wheelbase, at least I didn't get any, as far as screws go. These are M6 threads. This thing's kind of tilty, so I'm going to take it back off while I talk about that. I don't want it sliding all around making noise. I'm going to use these. They are, I believe these are 15 mil long. Let's see what I got here. Yeah, these are 15 mil M6 socket head cap bolts. I've got a bunch of these, black, chrome like this, zinc coated, that kind of thing, stainless. And I'm going to use a little washer here. It's an M6 washer. And I'm using the washer because these holes that I drilled in here a little bit, because one of the things I mounted was M8, so I had to make them larger. But this washer is going to engage enough metal over here that I feel confident it's not going anywhere. Plus, I'll have 4 of these in here. Now, another thing to consider here, 10 millimeter thick bracket. All right, so that means I got 5 millimeters left of thread to go into this piece here. Now, if you look down in here, I don't know how that's going to show up. These are kind of shallow, these holes here where we have our threads tapped into. Not a lot of depth there to get our screw to go into. And I'm going to see just how much depth that is. We just use our little depth gauge here. Slide this back down. I think I hit it again. Hang on. Got to be careful when you do this stuff. Let me just lock it down. There we go. So that's 8.2 millimeters as far as depth. So I'm going to have 5 millimeters minus about a millimeter on this washer. So that's about 4 millimeters in an 8 millimeter depth. Now, I could have gone with a longer screw, but then I would have to stack washers because it was way too long. This is the dilemma, right? When you're mounting something. Of course, if this plate was like 5 mil, it'd make a difference too. But this is 10 mil thick and a very nice solid mount for a deck mount anyway. So yeah, that's why I have to put one washer in there. I want to be able to engage enough of the hole on the bolt side. And I also want to get enough thread down in there. So I'm just going to hand tighten this down. And I'm getting, I'd like to have more thread in there, but I got 4 of these. So you have to weigh, everything that's going on. So I got 4 of these bolts that are going 4 millimeters into it, an 8 millimeter depth. I think that's going to be plenty. Remember, this is a peak Newton meter of only 9 Newton meters. So yeah, that's peak. So it's not going to be a ton of power. It's like having a big Thrustmaster or the Club Sport Fan Attack or something like that on here that, has 8 Newton meters worth of torque. So I think with 4 of these on here and tightened down properly, there's not going to be any issue. This is going to be very solid. I'm only getting about 3 turns on it though. Again, I just don't have another bolt without stacking a bunch of spacers and washers in it. And I think this is going to get the job done for me without too much. And I'll probably get another turn on them once I get the wrench on it. So that's how I'm going to mount it. All I'm going to do now is take this back off, and I'm just going to mount the deck first because it's easier to do it that way without the weight of the wheel on there. Even though this is not a powerhouse when it comes to weight, it's only a little over 10 pounds or 4.6 kilos. So it's not something that's going to kill me. But yeah, it's just easier to do it. Set this down into the wheel uprights, tighten up our bolts, right, with our T-nuts on the other side in the channels. Then we can come in, pop this baby on there. And that's what I'm going to do next. And when we come back, we'll take a look and see how all that went. All right, so we've got the R9 base securely mounted to our deck. And you can see I've got those bolts in the bottom there. Very secure mount on this cockpit. You can see I've got 3 bolts holding this on here. So it's very stiff as far as flexing in the lateral direction this way. Now there can be some flex induced if you have probably a more powerful motor and you're moving up and down because, this plate will tend to twist a little bit. Not quite as stiff as the front mount solutions, but still stiff enough, especially stiff enough for a 9 Newton meter peak wheelbase. The wheel on here is pretty tight. I don't get any flex out of it when I'm pushing on it as far as, where we're connecting here on the quick connect, which I didn't think we would. These are pretty beefy quick connects here with all those ball bearings in those sockets. So yeah, we've got everything mounted. It looks pretty good here. All I'm going to do now is get it cabled up. Go ahead and get the software, the MOZA tuning software app opened up, and then we'll take a look at all the features that we have in there. All right, so we're in the MOZA Pit House, our tuning software for the force feedback motor and also for pedals that we don't have connected, so we don't see any pedals in there, and also the steering wheel, also the display. I'll click on that real quick. So yeah, we don't have the display either, so we're just going to go right back to home. Now there's two ways to get to this motor tuning and of course the configuration, changing the configuration of our wheel, and that is to either click on this motor over here like that, which for some reason seems to default to their force feedback equalizer, but I'm going to go back to basic settings, or go back to home. We can do it this way just by clicking on more, and it didn't go that way. Interesting. So we can go back home, and there's the wheel. We can either click more here, and that gives us to the wheel page. So that's just a little navigation exercise. Important thing is, what are our tuning options? So let's go over to the R9 base and take a look real quick. Now, first off, we've got these different modes. These are presets that they provide for you from anything from GT to Rally. So as we change these, you can see some of these sliders will be changing also. Like that. Let's leave it on GT for now. And it defaults to 540 for their steering angle. You can change that steering angle by either clicking on the most popular ones, 720, 900, 360, or you can go up here and do something custom if you need to. Road sensitivity. Now what's cool here is they do have pop-ups, even though sometimes they're not the most intuitive information, but at least there's a pop-up telling you what should be going on when you're adjusting one of these sliders. So road sensitivity, well, that pretty much kind of describes it anyway. That's the sensitivity of the road field. Either it's going to be very tight and very grainy, or you can soften it up to where it's smooth as ice if you want it to be that way. So let's go over to where we're going to spend most of our time, probably, is the game force back intensity. Now, funny that they're only at 80% on the GT default. Go ahead and click that, make sure I'm still there. 80%. Well, I'm going to want that at 100%. I mean, we only have 9 newton meters peak on this motor, so I would think that, yeah, you'd want it at 100%. But then again, you might not. All this stuff is very subjective. Again, I'll be saying that often while we're talking about this stuff. Maximum speed of the steering wheel, little pop-up tells me the higher the value is, the faster the steering wheel returns to the wheel during travel. Steering wheel returns to the wheel during travel. Something lost in translation there, but anyway. They do give you a little description here. It says high return speed is more suitable for drifting, while low speed return can be more stable and accurate for regular racing. So yeah, that's defaulting to 40% out of 100. And I might be playing with that. I'd be playing with all this stuff just to see what it does. Mechanical back to center strength emulates a back to center effect at all times, suitable for entertaining racing games where the game itself has no feedback. As you can see, that defaults to 0 on GT Racing. Now that means it's a wheel effect. So MOZA is making the effect because the game has no power feedback. It's making up its own stuff. So that's obviously something you probably don't want to enable for most games. However, if we go over to, and I'm going to do a little experiment here, GT, it doesn't activate. Performance doesn't. Kart, watch kart. So apparently the kart games that don't have force feedback, and they defaulted that to 60%. Drift, nothing there, and rally, nothing. So only in kart would it be defaulting some kind of a setting there. We'll go to the GT and get rid of that. Mechanical damping, simulate a damping force independent of the game output. This is extra damping added onto the game's output. I'm not sure exactly if that means that this is just an effect, or it's a way for the dampen the wheel no matter what the telemetry is, and you dampen it within the wheel's firmware is what's actually doing it. And that's how the dampening works. But we're going to play with all this stuff, the sliders, and see what it actually does in real life. But yeah, if it's something that's an effect, I typically don't use that kind of stuff. Let's go to advanced settings, see what else is over here. Maximum output torque limit, 100%. So we can put it up to, back on basic, it says game force feedback intensity, 80%. But over here on advanced, it's actually max output at 100%. Interesting. I'm not sure why it's doing that. I would think I'd want it 100% on both, but we just had to play with it and see what happens. Let's see, what else have we got here? Hand-off protection. Okay. After opening the hand off the steering wheel, can be monitored, and the algorithm can control the steering wheel to remain in the middle position. In other words, this keeps the gyrations down if your wheel is oscillating. It'll let it oscillate to a certain point and then shut it down, apparently. So, in base status indicator, enable or disable the blue status lights in the front of the base. Well, it's kind of a dull blue, so it doesn't bother me to leave it on. Natural inertia. Okay. Inertia can increase the weight of the steering wheel to match the feeling of a real racing car. The maximum weight can be set to 5 times. It's at 100% right now. You can take it all the way up to 100%, or rather 500%. That's a lot. And that typically inertia gives a heavy feel to the wheel. The heavier you go with the inertia, the more you put on it. And as you're turning it, it's just a heavy. There's friction and inertia are kind of linked a little bit together when you're using the wheel and you're turning the stuff on. So you have to play with that to figure out what it's doing with their software. And based on, like, if you were using something else, it might be a little different the way this is implemented. So this is a compensation function, as I'm reading here, of mechanical damping and mechanical friction. So like I said, they're kind of mixing it in a little bit. Natural inertia will make the steering wheel feel more stable, but there will be a sense of stickiness. So there's always a line there that we're going to be playing with to try to get what we want. Mechanical friction simulates friction effect independent. Here we are again with the independent of the game output. It can be used to prevent steering wheel oscillation or simulate the steering rack of a car without power steering. So in other words, make it really hard to turn. That's friction. Inertia is as you're turning it, it keeps turning. And then spring would be return to the center. Then we've got over here speed dependent damping. Now this is a dynamic tool here. It's supposed to, on a linear basis, increase the mechanical damping of the steering wheel according to speed in the game, which is multiplied on a base of mechanical damping. So when the mechanical damping is 0, there will be none, right? So it's already at 100%, yeah, for GT. Now, the speed dependent, so that means how fast you go, how fast you're going in the game, from what I'm reading here. And then under that, we have a way to adjust the point of where it comes on. So the starting speed at which the speed dependent damping takes effect. All right, and last but not least, we've got the force feedback effect equalizer. Now this is a line on the bottom of all the frequencies that we'll get going over different things or different surfaces while at different speeds. So it starts out, and this is 100%. I don't know how well this is going to show up in the video, but it's 100% right here. Then we have 200, then we have 500. I'm not sure what the division lines are. Very hard to see here as far as where 300 would be and 400. But anyway, if body bumps and 80 kilometers an hour riding on a curb. Okay, so 80 kilometers an hour riding on a curb is supposed to have a frequency of about 10 hertz, what they're telling us. So we can increase that if we want more bumping going on when we're hitting the curbs. That's my assumption. We'll test it, obviously, and see what goes, see how it goes. But yeah, that's what this is. I think basically the higher the frequency, the less you feel it anyway, so you can actually turn it up if you want it to. The lower frequencies are obviously you're going to feel that more in the wheel than you will the higher frequency stuff. Like this one's right under ABS vibration. It's all the way down to 50%, it looks like. And right next to that, though, it's 100 kilometers, 160 kilometers an hour riding on a curb versus 80 kilometers over here riding on a curb. So the faster we're hitting the curbs, or the faster the speed is when we're running on the curbs, then the frequency will increase, obviously, because everything's faster. So that's why it's at a higher frequency over here. Now, I'm double clicking on this, and it doesn't seem like we can put an extra one in here. You have to use what's here. But you can go up, and you can't go sideways. So you can only go up with this. So it looks like it's kind of a fixed curve. They don't want you getting too crazy with it, I guess. So put that back down to 50, or just go back to default setting. There we go. And again, 80 kilometers riding on grass, 240 kilometers riding on a curb. It's just frequencies going up. So you could use this as a fine-tuning tool once you have everything else kind of set up the way you want, and you can come in here and in very small increments change the way this thing's reacting to different frequencies. That's what I'm going with anyway. All right, so that's all there is as far as control. It looks like there's plenty in here to get the wheel to work. The other wheels that I used from them or reviewed from them, I was able to get a decent feel, but it was always a little bit of notchiness around the center, which, you know, always kept giving me a kind of a digital feel on the, I think it was the 16 that I tested. But yeah, we'll see what this R9 can do based on what we have as far as to play with on control. Now we'll go check out the steering wheel. And you can see the screen here. It has this big representation of the steering wheel. And when we're turning a knob or using a button, you can see it actually represents that in the graphic. So it lets you know if all the buttons are working and knobs are working. One thing, that's one thing it'll do. But let's talk about what the functions are. First, we'll go to dual clutch paddles mode. First one is axis combine. Now, axis combine is what I would call dual clutch mode. And all we're doing is pulling both of the clutches in, and they light up yellow. If I pop one out, that will hit the bite point, whatever I set that, depending on the car I'm in. And then I'll let the other one out slowly to add the rest of the clutch. And then once it's all the way out, both of those paddles will turn carbon. So that means that everything is engaged as far as the clutch is concerned. Now, you can set the bite point over here. Depending on the car, obviously this is going to be variable. So we don't know until you get in the car and try it. Axis split. This is where we have dual axis mode. So each one is an individual axis. So I could use like a brake over here and a throttle over here and drive that way, right? Or we can go over here and hit the button. Button mode means that's what these are now, buttons. So you can add 2 more buttons if you need them, using your clutch paddles if you're not using them for anything else. All right, let's go to band knob mode. What is a band knob? Well, if you hover over the wheel, it'll tell you what these things are. This is the thumb. Let me get it to stop here. This thumb knob can be set in game. Of course, that's a thumb knob. So what is a band knob? These are band knobs, the encoders. That's what they're calling them, band knobs. All right, so first you can have it in button mode. And button mode is typically what I have it in. So every time I turn, let me actually make this smaller and I'll show you what I'm doing on the steering wheel. Here, bring in our steering wheel. Slide this over a little. All right. So if I turn one of these knobs, and it's smaller, you can still see it though turning blue. So it just acts as an incremental plus or minus, like a B button going this way to A button going that way. That's all. And it repeats that. So you can increment through things when you're in your black boxes or controlling things in game. Now there's also a knob mode, and that turns it into a selector switch. So now it actually rolls around the axis here like a clock. You can go clockwise, you can go counterclockwise, and it's just selecting different things as we turn it. But it works actually both ways. I have it, you can't see this because I got the wheel, but in my screen up here, it's moving my height of the driver up and down when I turn this. And if I put it in button mode, it doesn't do it. So in the knob mode, it does do it. So that's why I have it tuned there. So I have it in knob mode for that on this one. Okay. So anyway, let's go to stick mode. And stick mode is the analog sticks. We got one here and we got one here, here and here. I have it in D-pad mode, which is analog mode, which is like a regular D-pad. It's analog axes here. We can push up or down and get our axes. Now, you can also put it in button mode, which means now it's a button press. Every time we go left or right or up or down, it's a button press. So I can select in between my black box stuff. So, and that works pretty good. I like it in button mode. Engine RPM indicator switch mode. Okay, I've got the car running. Actually, I think it blew up. I left the car on too long. Get back in it. And you won't be able to hear it because I got turned way down, but I'm watching the RPMs and you should be able to see, well, hang on. I think my car is broken. Let me get back in here. Uh-oh. Pit for needed repairs. I'm going to have to request a new car, it looks like. See if that'll do that for me. Okay, let's get back in and see what happens. Yes. Okay. Now I've got my RPM indicator. I didn't realize I blew up my Ferrari sitting in the pit and let it run it overheated. Anyway, if you can see the lights here. In fact, let me make sure if I can turn these up. Make sure I'm all the way up here. Yeah, that's a little brighter. So the different modes we have, and you can see as I did that, it has colors that we can change. We'll get that in a second. All right, so right now is obviously an RPM indicator. I can turn that off on these selectors. So as I'm pushing the accelerator, nothing happens. Or I can just put it on so it just stays on. It doesn't matter what I'm doing. I'm going to leave it as an RPM indicator. Now we also have under that modes. Mode 1 is it slowly changes colors as it goes around, and the colors stay in position across this. And I'm going to go ahead and do this, show you what I'm talking about. It turns green, and then it'll turn the next color, which is orange. Then it all kind of fades into each other as far as the colors go. This is orange, then it turns into red, then it goes blue, and then there's a little bit of a green on the other side down there. So, but they all stay together as individual colors. Now, if you change it over to mode 2, then what happens is, as we go through the RPMs, it changes the whole color change. See, it's all green right now, then it turns all red, then it turns all blue, and then flashes green when it flashes. So depending on what you want, really, it's totally up to you what you want to do there. Now we have the, let me have to open this up a little bit here. Okay. Now here we have, let me just push this over here because it's not going to show it in the other representation. The timing. So this is normal. If I put this on normal, and you guys can't see this, but it doesn't sync up with the RPMs on this Ferrari. I'm in the 488 GT3 Legacy car in iRacing. And if I have it in normal mode, it starts flashing way before it gets even close on the car to where it needs to be flashing. So if I put it in lead, though, it makes it even worse. So it's like one indicator comes on before it starts flashing. So I use late on this car. Now, we can also go to custom. So if none of these work well enough for you, you don't like it, what they're doing, then you can just go in here and do what you want to. Just raise them up and down and match whatever your car's RPMs are doing. And you can always change it back just by clicking on here, right? I'm using late, so that's why I'm keeping it. Now we have the colors. Now the colors are simply that, and the colors as they go across here, if I want to change what these colors are, then I can go in here and just drag and drop the colors. I think I got blue up here. I could actually go and make these. I think these were all purple or something to begin with. But you can see I'm just dragging the colors over and dropping them. That's all you have to do. And of course, our brightness piece, little slider over here for brightness. Let me see how far that goes. Okay, it goes way over there, huh? Let's make it really bright. Okay, I'm going to get it back down here. See if we can see what it's doing here. So yeah, now it's a little bit brighter for sure. All right, so that's it as far as the settings go. Now I'm going to talk about the wheel itself here and these programmable buttons we have for the actual wheel itself. Now, you can change the colors on all these buttons. And they say 9 different colors. I'm not sure it's exactly 9, but there might be, some kind of a bleed through that they're talking about. But anyway, to change the colors on these, when you first get out of the box, they're all red. And when you first crank this up, by the way, or first turn the motor on, it does a cool little sequence. And I'll show you that here, where it's kind of sweeping back and forth, the lights and all the buttons are turning purple. It's a pretty cool little startup sequence. At least I thought it was. Now, if we want to change the colors of these buttons, it's very simple. We take our thumb encoders, and they are also buttons, by the way, so you can press them as buttons. But you press them both together until we get a flashing light up here, then you're supposed to let go, and that's supposed to put it in debug mode. Now, I have done this. It usually works fine, but sometimes it doesn't catch it the first time. You might have to do it twice. So I'm going to hold it in. I see it flashing. I'm going to let go. So if everything's working right, and we're in debug mode now, this purple button here, if I press it, it should change colors, and it did. Now we're in kind of a dimmed down purple, if you will. Then we get white. We've got red, which is the default color. And then we've got a yellow or gold. And then we got more of a yellowish, maybe even a greenish yellow. And then we go to a regular green. And then we get a less of a green. It's kind of a lighter green. And then we go to blue and back to the bright purple that I had before. I'm just going to leave it there. So you can cycle through each one of these. You can do that too. And then once you're done, and you can't forget this, because as soon as you get in the car and you start pressing the button, it's going to start changing colors again. You go, oh, it's still in debug mode. So you just hold it down again so it flashes. Let go. Now if I press the button, it shouldn't change, and it doesn't. Simple enough. So there it is. That's what we can do with the wheel as far as using it in the games. So I think it's pretty good as far as the functionality and the different feature sets that they have in this wheel. I like what they've done with this wheel so far. But yeah, now it's time to get in the car, and we're going to do a little live tuning session and see what this motor can deliver. All right, guys, this is going to be a live tuning session just to see what this software is capable of doing as far as getting a decent feel to the wheel. And we're going to start out in basic settings and in GT default configuration. So this is the default configuration that'll load when you press GT. Press performance, it changes a little bit, obviously. We're going to go to GT. Just out of the box, see how that feels. Now, in my iRacing settings, I have this set up correctly to 9 newton meters, and I'm currently running 35 newton meter for force feedback, max force. And again, that's only for iRacing settings. So we're going to go ahead and get out on the track here and see what we feel. There's a faint bit of notchiness around the center, just a faint bit though. Of course, that's at default settings. So we're going to get up to speed here. And right away, right away there's something that I don't like. As your speed is going up, the wheel gets, they're loading a lot of friction in it. And I'm trying to think of why they would be doing that. Maybe oscillation control? So I'm up to speed. Let's see how we're oscillating. Let's get up to a little over 120 miles an hour here. Get down the straight. Let go of the wheel and see what happens. Yeah, see the oscillation control on this? So what they've done is put a lot of friction in that to give you some detail and control the oscillation at the same time. Now, oscillation is something that doesn't bother me. I don't care how much a wheel will oscillate as far as when I take my hands completely off the wheels, because I never do that. If I can control that with just one finger like this, so as long as you have something on the motor itself can feel something resistance as far as, not, except for the weight, obviously, of the quick release in the steering wheel, it's going to be smooth, right? So you see some movement, but that's just me going over bumps. See how it moves? And then it's smooth again. So I would never take my hand off the wheel when I'm racing anyway. So it doesn't bother me if something oscillates. And you can see how it also stops the oscillation. So I'm thinking that this speed sensation is what's doing that. Let me go back up to speed one more time here. Then we'll talk about, yeah, as soon as you get up to speed, man, this thing is, the steering gets, there's a lot of friction being put into it. It gets pretty heavy. Trying to turn it from side to side, yeah, it's like a, yeah, I don't like that at all. It feels very thick. And I think I know why they're doing it. All right, so first thing we're going to change, and we're going to have to go over to advanced settings to change this. So let's switch over there. Speed dependent damping. It's at 100%, and a point of entry is, or when it starts, is 90 kilometers an hour. So that means once I hit 90 kilometers an hour, the faster I go, the more damping, or I'm sure they're using the friction element to get that, you get in the steering wheel, which makes it harder to turn. But it keeps the oscillation down. What we're going to do is, first off, take this up to like 250, 60 kilometers, which this car probably won't get up to that speed, but let's see what we got. And we'll go down the straight here. Yeah, right away I can feel some difference. There's a little bit of notchiness as I'm turning, but let's see what happens when we go down the straight here. I'm not going to go very fast. Yeah, I'm already over 90. Now it's gone. Yeah, this is much more to my liking. And again, I want to reiterate, I might say this a couple of times, this is very subjective stuff here. Look at the oscillation there. So it's very subjective. Just because I like something doesn't mean you're going to like something in a setting, right? We're all different. So anytime you see anybody reviewing a wheel and telling you how it feels and this is the way to run it, just take it all with a grain of salt, including what I'm saying, because you don't know until you have it actually in your hands and you're tuning it what you're going to like. All right? So just keep that in mind. Now, I like what I'm feeling because it's not there anymore. The thickness is gone. I still get detail. In fact, I'm getting a little bit more detail and a little bit more notchiness around center because I've taken that off. Let's see what happens when we let go of the wheel. So you can see it really starts to oscillate more than it was before. But again, just one finger on this will keep that from happening. And go up to speed again here. Let's see if that still holds true. I'm pretty sure it will. Yeah. See, I got one finger on it, and there's no oscillations. Take it off, and you can see it starts right away. See that? But then they have a safety feature built into this somewhere that stops the oscillation if you take your hands off the wheel. Of course, it might stop the oscillation when you're turning, though, and you end up running into the fence or something. Of course, the key thing here is to never take your hands off the wheel. or at least leave one on there all the time like a real race car driver would do. And also remember, we're trying to make this feel as analogish or as realistic as possible within the limitations of a force feedback wheel and what it does. So yeah, oscillations, you'll never get that, well, hopefully you'll never get that, or your alignment's totally screwed up going in a real car down the circuit, right? You won't get that kind of stuff. See how it stopped in a turning position there? So just keep all this in mind. I'm trying to get as close to analog as I can, but I'll never get there because of what we're trying to do also with the force feedback to let us know what the car is doing, which you don't need in real life, because obviously you've got GeForce and you've got a real steering wheel in your hands, and everything is analog at that point where your body understands that very well and how to respond to it. Or yeah, you're not going to be a very good race car driver. So I like taking that off, but now I've got some notchiness around the center as I'm turning it. So let's go in through this turn here and see what we have. Yeah, it's a little bit, yeah, I'm not sure I'm liking that. I'll tell you what I'm going to do here. Let's go the other way with this. Instead of raising the speed where it activates so it doesn't activate, let's just take it off. See what happens. Still a little bit of notchiness around the center. Not a lot. And the rumbles are there, but not real definitive. So yeah, now I don't have that thickness when I'm turning at speed, which allows me to do minute corrections quicker than trying to fight, you know, a heavy wheel that has a lot of friction dialed into it. So, and when I'm in the turn, there's no notchiness because the wheel's obviously not moving back and forth when you're in a turn. So you have to keep that in mind also. When I'm talking about notchiness, it's just transitions. I'm going one turn to the next turn, and I'm transitioning across the center in that stroke. You feel a little bit of a ripple going on there, a notchiness, I like to call it. All right, let's see what we got. Yeah, much better detail going across, or around rather, turn 17 here. A lot of bumps on the straight here at Sebring. Again, one of the reasons I always use this as my baseline. Feels a little digital as far as the bumps when they're hitting. Not totally objectionable though. All right, so I'm happy with that off. Let me do something though. Let me pull this up back to 50 and see what that does, if that puts anything at all on the wheel. Yeah, right away I can feel a difference. Even though, oh, well, of course I do. All right, I have to pay attention here. My speed is at 0, so it's heavy right away. So let's go ahead and just put the speed way up again and see if there's a difference. I don't feel any difference. With it all the way off or back up to 50%, as long as the speed is off, then it's not going to engage. And remember, it's a dynamic issue anyway, so the faster I go, the more input it gets on it. But yeah, it's not there. All right, so you can just put the speed up, and it feels pretty much the same to me. Good return spring for this. I like how much there's as far as the return of the wheel, which we call center spring usually. All right, so what else can I do here? Let me go back to basic here. Whoop, try to stay on the... Okay, I'm running off the track. Okay, so road sensitivity is 9. I'm going to leave that alone. It feels pretty good. Intensity is only 80% though. If I go back to advanced, you can see that maximum output torque limit is 100%. So I'm getting 100% torque from the wheel, but the game force intensity is only at 80%. So what the game is sending me, they got that dialed back down to 80%. I'm going to put that to 100 and see what the difference is. So I should be getting the full 100% telemetry waveforms that the game is sending now. We were always at 9 newton meters though, as far as the motor torque is concerned. Yeah, I already like that. It gives more weight to the wheel, if you will. It was a little bit light. Took that dynamic stuff off. Now we've got more weight. Now I'm feeling a little bit better about what's going on. We still have some notchiness around center, but again, once you're in a turn, you don't feel that. If you see the wheel moving, that's because the bumps in the turn are causing the wheel to react, which is what you want, obviously. So let's see. This is not bad. Feels pretty good. Again, I can't get rid of that notchiness, it seems. But it's livable. I mean, it's not like it's horrible or anything. But I prefer not to have any, personally. But again, sometimes to get what you want in a force feedback wheel, you have to, well, compromise. And there's going to be some oscillation here. I'm only in 4th gear, and watch what happens. So you see it stopped, though. But again, it won't do that as long as I have just even a finger on here. It's hitting road bumps. You see it vibrate a little bit from the bumps that we're hitting in the road. But yeah, see, it just doesn't do it until you let completely go of the wheel. Which, again, I'm not sure why you would be doing that and then complaining about oscillation. You're not supposed to be letting go of the wheel. This is feeling pretty good, actually, except for the notchiness that I still haven't. It's noticeable. It's not real faint or anything, but it's there. But overall, I'm at max torque here, and using all of the waveform that's coming from the telemetry feed, seems to be doing pretty well. Now, the only question is, my mechanical damping is set at, let's see, back to center strength for 0, maximum speed of the steering wheel. I'm going to turn that down to 30, because that's supposed to be, you know, the higher speed for like drifting, but you don't want it this high speed for a more neutral type of feel in the wheel. So I just took that down 10 percentage points, or 10 points on the line. So that should have slowed the wheel down a little bit as far as when I'm turning it and it's coming back like the return spring. Essentially, that's what that is. I would say center spring is what we call it. Good rumbles there. Good rumbles there. Good transitions back there for the concrete, the asphalt. The same here. As I'm coming back on the asphalt, it smooths back out. I can feel the bumps in the concrete patches. All right. Again, good textures across that concrete patch. Decent rumble. Not too much weight to the wheel. I'm kind of happy with that, I think. Mechanical damping. Okay. Now what we're going to do, and we're still in basic. We still have a damping over here, but that was the speed. This is friction. I'm happy with the friction. I'm not going to change that. If I turn this friction up, it's just going to make it harder. The wheel gets heavier to turn. That's what friction is. Inertia is down to 0. We don't need any inertia. Inertia is just as you start turning the wheel, it makes it, the weight of the wheel increases the inertia. That's what they call the inertia. In other words, you're starting the turn, and the force of that helps turn the wheel. So typically I don't have much inertia in a wheel anyway, but I'm going to leave that. Friction, I'm going to take that up to 50 just to see what the difference is. And that's an advanced. So let's see what we got. That's added some weight to the wheel as I anticipated. But when I did that, and we still got oscillations, so that didn't change. That really didn't, all that did was make the wheel heavier, and it dampened down my, go ahead and put that, I think it was at 35. I'm going to leave that alone for now, because that started dampening down my force feedback. So now I'm back to where I was. What else can we do here? Let's go back to basic. I think there's one more thing I think I was going to try here. The mechanical damping here. Can I get more detail by turning the damping down? Let's find out. Let's go ahead and take it down 10 points. Of course, this is a long straight that's not that bumpy, so we have to wait till we hit turn 17 down here to see what the results of that change are going to be. All right, so we took 10 points off the damping. Here we go. Yep, more detail as anticipated. Of course, this is not a good straight to try the the notchiness test around the when I'm turning the wheel because it's so bumpy. You can't tell what's notchiness and what's bumps. It feels pretty good, actually. I'm glad. I think I might leave that there. Dampening's off, and again, we're getting more of the digital feeling or the sharp feeling of the bumps or the hits when we're hitting bumps and going over curbs is getting more defined. And yeah, the notchiness is still there. And it's a little bit more pronounced, which is, like I said, expected. Less dampening, more digital feel to it, but more detail at the same time. And you see how it's jerking around now. It's even snappier on the oscillation when I took that off. Which again, this is all making sense, the way this is working. So again, what's your compromise going to be? It's up to you yourself, what you think you need. Good detail, again, a transition is a little bit sharper than it was before, but now I'm getting that kind of a sharper, more intense bump when I go across bumps, which you may or may not like. I like that, but I'd like to see if I can get that wheel smoothed out. I don't know, I'm kind of torn here. It's easy to change your mind from car to car too, by the way, on what you think you want. So when I'm turning like this, initially I can feel a little bit of a ripple. Then it obviously, when I stop the turn, the physical turning of the wheel, then obviously it goes away. Like that. It's smooth as silk through there. Smooth through here, except for the little bumps that I'm hitting. So it's really just a transitional thing. And that's why it doesn't bother me a lot if I can get it. Some of it's still there, but that's totally subjective. Some people might hate it. But it's nice if you've ever had a force feedback wheel where you get the detail you want and you get smooth transition when you turn the wheel. That's yeah, that's really great when you can get there. All right, so a little torn on the mechanical damping. Let me take it down another 10 points. See if that makes anything more objectionable. Now, I'll tell you what, the notchiness is there, but it didn't increase. It doesn't feel like it went up. Maybe. Let's see what we got going around here. A little bit too tight. Oh, too loose on that turn. Okay. So, I'm thinking, I'm going to go through turn 1 here. It's a bumpy turn. Actually, I kind of like it. It's pretty lively. And the notchiness is still there. I don't think I'm going to be able to get rid of it and get what I want. So, let's go back to, I'm going to turn road sensitivity up and get my damping back to 45. 10 more points of more damping applied. But I went up on road sensitivity. Let's see what effect that has. Yeah, notchiness went up. And that shouldn't have done that with me increasing the damping, so that's too much road detail. Let's go off some bumps here. It's starting to feel a little bit, yeah, digital. A little sharper, which you might imagine. Obviously, we've just cranked it up. Okay. Yeah. That's too much. And everything just increased as far as detail, which means it works. I'm going to take that back down to 9. I'm even going to take it down to 8. Let's go the other way real quick. Ooh, notchiness has gone down. Good, good. Heading in the right direction. Ooh, still good detail there. Try this rumble strip out of this turn. Yeah, it really didn't. The detail's less there. Tell you what, I might try to fine tune it with that equalizer and see what we can do with that. Because it still feels pretty decent. And the notchiness is less. because we turned it down, obviously, road sensitivity. So it all kind of relates to each other. And you change one thing, it's going to change the other thing too. All right, so here's what I'm going to do. Let's go to, I'm kind of happy with this. I think I'm pretty much where I need to be, even though I may tweak it, putting more hours on this wheel. You know, it's always a possibility. So now I'm going to go to this equalizer thing, and it's kind of not too intuitive, I guess, is a way to put it. We've got 0 hertz to 100 hertz down here. We've got a line here that we can move these guys up and down. Currently, 160 kilometers an hour and ABS vibration are kind of together there. And we're at 50% of 100% of 25 hertz. And we've got this here operating the wheel. I'm not sure what that means. Body bumps. And that's kind of in between the 80 kilometers an hour riding on curb, which has 2 adjustments in here. What I think I'm going to do is I'm going to take the one over here and put that up to 200% and hit 80 kilometers and ride on a curb and see what that feels like. Oh, if I can go right. Let me go the right way here. Okay. All right. You see, like the clouds are over Sebring right now. See how dark it is. So the clouds will go away in a minute. It's probably pretty dark on the video now too. That's that dynamic weather we always wanted, right? All right. Yeah, there's something more as far as the detail going on here. Of course, I'm going over 80 kilometers now. I'm going to have to wait till I get down here in this S. All right, so now we're down. We're going to be in that 80 kilometer when we're accelerating. So that did make a difference. The road bumps are definitely more intense. So with that in mind, let me go over here to, let's go over to ABS vibration 160 kilometers an hour. So that means I should have the same thing there. I'm just going to put that up to 150%. So now we should be able to get up to 160 kilometers an hour down here. Yeah, okay. I just dropped the wheel off on the grass there. Of course, we're not going to be doing 160 through here. But I tell you, the center, it seems like the center has, the notchiness is definitely a lot less now. It's still there faintly, but it's not that bad now. Okay, let's go ahead and just do some high-speed running here. So it does increase the details. It's like a fine-tuning tool. Once you've got where you think you want to be, you can go in here and play with these sliders. That was good rumples. One there. Good rumples. Good there. I like that. All right, that was good too. And that was at our higher speeds. So if this is good, oh, really good rumble strip vibration there, or texture. All right, so we've got one more we can do this with. Now this is, again, the way they label this is a bit confusing for me. May not be for others. We got riding on the grass at 80 kilometers, 240 kilometers on the curb. So we're going up from 160 to 240. So that means at the higher speeds, I'd be raising the detail, I'm guessing. And then we got 60 kilometers riding on sand, which would be very thick feeling, and it seems to me it would dull things down. But you can see our frequencies are going up too. So I'm going to take this one and let's take it to 150, and we'll take 150 on this one. My curve's changing a bit, isn't it? All right. And again, this is very subjective stuff here. I tell you, the notchiness is about as minimal as I felt it on any settings, which I'm happy about. I'm still getting some detail too. Or actually, I'm getting a lot of detail. Go through here. Yeah, and it's not too digital feeling. It's kind of a smooth bump when I'm hitting those bumps. Let's see. Notorious turn 1. Yeah, it's really turning the detail on at that high-speed turn right there. I mean, I felt every bit of the texture there, which, again, may or may not be what you would like. But yeah, I like this better. And the notchiness around center is about the least amount that I've had it in the settings so far. All right, let's try our transitions up here. Yeah, there's definitely more sharpness or detail, clarity, if you will, to all these bumps and curbings that I'm hitting, and the bumps and the curves, the transitions. This is pretty lively, but not in a bad way. Yeah, I felt all that going over when I usually swing wide there and catch some of the grass. Yeah, actually that was great on that rumble strip. It's the best that rumble strip has felt so far. So this is pretty cool. That this thing actually works. I wasn't sure the first time I saw that when I did my first MOZA review, just what the heck they were trying to do there. But now that I'm using it on this wheel, I can sense what's going on. Good rumble there. Yeah, the rumbles really come alive here. But then again, so is everything else, but not in an irritating digital way where it's real sharp knocks on the wheel when you're hitting bumps and things. It's smoothed out. I could probably go back and put a little damping in this, I think, based on what I've got so far. So that's what I would do next, I think. Yeah, this is, although I'm not sure I'm what you want to do at. It feels pretty good to me. Again, subjective, right? Somebody else would get this configuration and go, oh, this is horrible, which is fine. They just don't like the same things I like. And the bottom line is to get this wheel, it feels really good around here. I mean, every little bump, you're feeling it. And it's good power. You know, also, I wanted to mention, peak 9 newton meters. I did a review on a couple of 10 newton meter wheels, and to be quite honest, I can't tell the difference in the real analog world when I'm using these things, when I have them turned all the way up, which I'm not surprised at. I mean, what's 1 newton meter peak? I mean, really, can you tell the difference when you got people running 20 newton meter wheels and turning them down to 15 newton meters because they don't want that much power? Still a little bit of notchiness there, though. That's never going to get all the way gone. All right, one last thing I want to do. Let's go back to my mechanical damping. I'm going to put that up to 50%, just to see where that is and if it does anything better on the notchiness. Yeah, it's still there. Maybe a hair smidge fainter than it was. That's still good detail. Wow, really good across that one. Transitions are good, but not sharp as far as so sharp that it feels too like artificial. Good through there. Actually, that bit of damping didn't hurt anything. If anything, it just took a little bit of the abruptness or sharpness out of something. Let's try this. Yeah, that feels pretty good, actually. I might play around with the damping a little bit more. I'm going to turn that up to 55. All right. So you guys are probably wondering, is he ever going to find something he likes? Well, it's such a short little thing that I'm doing here on the video. Oh, wow, that felt good. It usually takes some time to get these things dialed in, but I just want to give you guys an idea of what I'm doing, and as I'm changing these sliders, what's going on. Still good rumble there. Of course, we're going to get the oscillation, but as long as you keep a finger on this thing, you can see it's moving a little bit. That's just because there's some bumps in the roads that we're going down here. This long straight. All right. Turn 17. That feels pretty darn good. Still a little bit on the edge as far as all the bumps coming down the straight. the finish line start straight. All right. I think I'm done. Now, I could go back and tweak some of the settings, obviously, and I may do that as the more hours I put on this wheel. Because there's always, you might change your mind about what you felt before, and you want to maybe put some more damping in or take some out, something like that, and go back to this force feedback effect equalizer and change something in there. Take a little bit of it out or in, whatever you want to do based on the frequency and what they're saying up here. Again, not the most intuitive thing, but once you use it, you can tell what it does. So that's the important thing, to be able to use it and tell what's going on. So that's going to be it for our live tuning session. I'm actually going to save this setting. And let's set it up as that one. I'm going to overwrite one. There we go. And now what I'm going to do, I'm going to import a setting that I had before. Just see how far off I am. Okay, so I didn't have as much of this in, or that. Oh, I hope I didn't hit default. I thought I had some more of this in. So actually I turned up more detail this time than I had on last time as far as the fine tweaking of this. Mechanical friction was at 15%. Let's see. Yeah, I had this turned down. Yeah, that's something I did not like. It was just too heavy. Although it did correct the oscillations. 9, still the same there. 100% there. Speed, 30%. I was right there. Mechanical damping, oh, hey, check it out. I was at 55%. So I'm pretty close, except for the equalizer, to where I was before. Okay, that's cool. So that's our live tuning session. And again, take this all with a grain of salt, as you should with any reviewer telling you how a force feedback wheel feels. We're in iRacing at Sebring in the Ferrari 488 GT3 Legacy car. This is a great track to test any force feedback wheel, direct drive or otherwise. And right out of the box, I have to say about the MOZA wheel here, as far as the wheelbase goes, the default configuration for their GT setting had some really heavy feel to it, like somebody had put a bunch of friction in it. And friction means, when you're turning the wheel, it just makes the wheel feel very heavy. And they have this feature in the Advanced tab, if you go look at the Advanced tab. Now, I explained all this in the tuning session that I did in this, did a little live tuning session. We went through all the settings and discussed that. But what I ended up doing was turning off the speed-dependent damping feature. And what that does is the faster you go, because of speed-dependent, the more damping, or what I'm calling friction, because that's what it felt like, the heavier the wheel got, which didn't give me the ability to give snappy inputs or corrections that I like to do. I had to really push against the wheel to get that done. Now, I think that the reason that they were doing that is because this wheel tends to oscillate very easily, at least at the detail settings I have it and the damping settings that I have it at. But it only oscillates if you take your hand off the wheel. And if you even have a finger on the wheel, it doesn't do it. So it's really not an issue for me, and I think for most people who are driving and racing, because you never take both hands off the wheel unless you're going to crash, and at that point, it really doesn't matter. But yeah, they have a safety feature built in, though, that it'll oscillate a little bit and it'll stop. So it won't oscillate but so much before it just catches it and stops it from moving. So anyway, this speed damping they have in there, I just turned it off. And once I did that, then it freed up the wheel. And then I was able to start working on a decent configuration that I liked to get it to handle correctly. And the good news is, with the settings provided by MOZA's tuning app, I was able to get a pretty decent configuration. I had good detail, I had good speed in the wheel as far as what I felt like I needed. And by the way, as we discuss these things, like I always say, this is very subjective material here. So yeah, take it all with a grain of salt, because you may not like what I like. And that goes with just about anything, you see on YouTube as far as reviews go. Yeah, take that all with a grain of salt, because they don't know what you feel when they're talking about it, neither do I. So I'm just going to give you a basic explanation of what I think I'm feeling and try to convey that to you. Now, like I said, I was able to get a setup on this wheel that was pretty comfortable for me. And I had it at 100% all the time, as far as the torque in the motor, and also any of the torque telemetry that I was getting from the game was at 100% too. Default is 80%, but I just went ahead and put that at 100. Again, this is a lot of fiddling to be done with the tuning app, just like any other tuning app, to get things the way you want them to. But I found that after about an hour or so of figuring out what these sliders were doing and then getting everything dialed in to where I thought I wanted it to be, then I actually went out to their feature that's called the Force Feedback Effect Equalizer. And this thing is like a finite tuning on the tune you already got. So this, you can go in there by frequency and raise or lower the amount of effect we're getting. And this is all software generated, but it does allow you to tune some things in or out that you might not be able to through the basic and advanced settings. It really turned out to be pretty cool because I was able to actually improve my settings from the basic and advanced settings in that equalizer. It kind of surprised me, to be honest, but it did work out for me. So I was able to get a good configuration. Now, there was still some notchiness or some ripple when I'm turning the wheel from left to right. I got it to be very faint, but it's still there. Yeah, it's noticeable when it's still there, but at race pace and you're racing, are you really going to notice that? Is it a deal breaker? That's totally up to the person driving the car. If you don't have a wheel that is very smooth across the center when you're turning back and forth, then if you've never had one rather, then yeah, you won't know the difference. I think you'll be pretty happy with it. I would like to do something different though, because it's just a little bit too much for me. I just like it smooth, completely smooth, and have all the detail I want. I know I'm dreaming, right? But there is one wheel that I was able to get that out of, the one I drive every day. Now, the steering wheel itself, doing a great job here. I really don't have any complaints, except the black housing on the back is not as stiff as it would be if it was an aluminum housing in the back. So I noticed that when I was sitting there pushing the wheel back and forth, but when I'm driving it, I really couldn't tell the difference. It was just doing what it's supposed to do. I was able to control the car. It didn't feel soft or anything like that. The connection with quick release was very good. The shifters were excellent. I really like the shifters, very crisp, very tactile, and I really like shifters like that. But on the other hand, they're loud. So yeah, everything worked as it should here, so I really don't have too much to complain about except for that little bit of notchiness, and I'd rather see an aluminum housing on the back of it. So, and again, that's, you know, me being picky and some of the personal preferences I have for a direct drive wheel when I'm using one. So yeah, that's about it for the driving segment. Final thoughts on the R9DD wheelbase and GS steering wheel kit. Out of the box, this kit presents as a professionally manufactured product, keeping in line with what I have previously seen from the guys at MOZA Racing. Fit and finish are good everywhere I looked. The R9 has a 9Nm peak torque rating, which is what I consider a minimum entry power level when it comes to direct drive force feedback wheelbases. The electronics used in the R9 look to be a result of a well thought out design, using inductive coupling to deliver wireless power to the GS wheel. Data communication between the R9 and the GS is provided by a wireless transceiver arrangement, with optimal antenna mounting on the front of the motor casing and the back of this GS wheel. The GS wheel also has a very good looking electronics layout. The GS uses a 5mm thick piece of forged carbon fiber as a supporting frame for the electronics and grips. This gives the user a solid, stiff feel in use. The GS uses contactless sensors in its shifters, which are sporting magnets and a 3mm thick carbon paddle set. The shifters are a pleasure to use, providing a tactile feel when actioned. The shifters are also loud, which most good-feeling shifters are. MOZA does provide some rubber damper bits to quiet them down if needed. The GS rotaries have positive-feeling detents and very little shaft play. Using MOZA's Pit House tuning software, you can set controls to perform different functions as needed. I was able to dial in a suitable configuration using the Pit House app, which allowed me to turn consistent lap times. There was some notchiness when turning the wheel back and forth that I could not completely get dialed out and run the amount of detail that I need to properly control my car. And there was still some faint digital feel to the wheel when running over curbs and larger bumps. Not something I couldn't live with, but something that needs to be noted. Overall, considering the price point of around $940 for the R9 direct drive wheelbase and the GS GT steering wheel, I think MOZA has done a good job here. It's great to see more sim racing manufacturers coming out with new and relatively affordable direct drive wheelbases, with some pretty good looking and performing steering wheels to go along with them. I'm Barry Rowland. Thanks again for watching the Sim Racing Garage channel. Don't forget to hit the subscribe button. And if you would like to help support what I do here at the SRG, visit my website at simracinggarage.com.